Hello, everyone. Welcome. My name is Isabella. I work with marketing here at TATOT, and I've got Eduardo Bogo with me, who's an automation engineer here at TATOT. And today we're going to have a little bit of a different approach. We're going to be talking about some AI basics for industrial software. So even beyond TATOT and frameworks, what are some of the basics around AI you really should know before you start working with it? We'll go through some definitions, explain some of the basic stuff around it. And then at the end, Eduardo is going to show us an example as well, how you can get started. So yeah, let's dive into it. So first things first, why AI and really where you should not be using it. When we think about AI, a lot of people are worried about it replacing us, and I totally understand. But really, that is not the goal and should never be. AI is really fundamentally made to be a decision support technologies. What does it mean? It means that it really shines where you have a lot of data, but some uncertainty, and the patterns are hard to express. There are no like explicit rules that you can find. So that's where it really excels because it finds you those patterns, pattern recognition, and prediction. Those are the top two things that it does. It can really help you make sense of a lot of data. What does that mean? It really handles that uncertainty much better than just some rule-based logic. But that also means it's really not suitable when we think about real-time and safety critical control. Really, it's most effective if you're using it to generate insights, recommendation, or prediction, but you're still using like rule-based and control systems to kind of execute actions more reliably and safely. Just real quick, what is artificial intelligence? Like basic definition, right? Very broad term. So it includes many different types of technologies and system types, from machine learning to other kinds of language systems. Eduardo is going to explain some of them more related to the industrial space. But I got some example here for you guys. Chatbots and assistant, that is everyone's favorite, ChatGPT, the famous one. But anything like image and speech recognition, recommendation energy, all of those are also considered artificial intelligence. So when we get to ChatGPT and those families, that is one of the large language models. What is that? It's a very specific type of AI, really designated for language tasks. So it's specializing in understanding and generating language. It's trained on large connections of text. And the way it works is that predicts the next token in a sequence. So based on context, it figured out what you're going to say next. That really helps you generate current text, answer questions, summarize information, and even generate code. But it's important to understand that it's only thinking about the next token, and it doesn't really understand the way we humans do. So they model language patterns, and that's why they have that name, large language models. So it's not based on a specific truth or even thinking and logic as we understand it. And that's important when we think about strengths and limitations, right? So what are the strengths around it? It's great at natural language interaction. So really great at explaining stuff. Rapid information synthesis, I think that's where it really shines. It really lowers the barrier for us humans to interact with complex systems. But they also have important limitations, and it's important to understand. So when we use those tools, we're not asking it to do things that it simply cannot. So they can and they will make things up. So they generate incorrect or fabricated answers all the time because they don't really reason, like I said. So you really got to make sure that you have guardrails and validation attached to that. Because they are powerful interfaces, but they are very unreliable if you're using them as like your main decision maker. I even put in here a little graphic that I think it's useful for you guys to see. So we can see where it really fails. So, and that is when things are too open-ended or too specific. And what does that mean? Open-ended, it's really when you are requiring creativity. You want it to be human. You want it to give you more ideas and all that. And sometimes then that's where it really starts making stuff up. It's not clear. It really just giving you generic answers. And then context is specifically, what does that mean? It means sometimes you cannot give the large language model all the information. Sometimes there's more stuff attached to it. You cannot understand the human aspect, or there's history on your process that you cannot fully give it to him. The more specific it gets, the harder it is for it to truly understand. You can and you should be training um, your LLMs as you talk to them. But even beyond that, if you get too much and too deep, it's just not going to be able to give you a reliable answer. Do you think that makes sense, Eduardo? Anything you want to add?
Yes, the LLMs right now helps us a lot, and specifically when we talk about machine learning and MCP, the topics we're going to talk about right now, you can also use the LLMs to help you understand those, even if you don't know much about that, because the LLMs have a lot of information and it gives you in an organized way that you can use.
Perfect. I think that's a good point as well. And Eduardo is going to show an example at the end of this, which is really how you can use the LLMs to get you started, because that is kind of like the first phase of AI that most people are interacting with right now. And it can be and it should be a powerful tool. Just keep in mind that it does have limitations. So let's get into some specifics on the industrial space. Eduardo, explain a little bit to me, what is machine learning?
Okay, so we're talking about AI, and machine learning is inside of AI. You can tell and train a machine to identify patterns in your data. So machine learning is all about inputs and outputs. When you get in the inputs the process variables from your process, you can have conclusions, predictions in the output. So this is what the machine learning does. And inside of machine learning, we have many algorithms types that we can use. For example, the prediction. When you predict a value, a future one, you can classify your data, you can identify anomaly detections, and much more. But these are one of the most used ones.
Yes.
And also, we have a couple more, like binary classification, where you can train a model to tell you if some process specifically will fail in the next 24 hours. It could be, oh, with these process variables in this value, uh, will the product pass the quality control or not? And when I mean process variables, I'm talking about temperature, pressure, flow rate, that kind of variable. We also have the multi-class classification, which will tell you which is the defect type. So it can be overheating, it can be corrosion, bearing issues. The machine will tell you based on the inputs you give what can be the problem. You also have regression, which is a prediction of a future value. You have time series forecasting, which is very similar to regression, but it has the timestamp also when you train the model. So you may have a column with the timestamp that's with the information when that happened. You can have the normal detection, which will tell you if the situation of the specific machine is a normal behavior or not. Usually in this one, you train your machine with healthy data, and then when it goes out of the pattern that it was trained for, it understands as a defect, and it says to you that this is abnormal situation. You also have clustering, which will classify your data. Okay, that's a normal stress level, inefficient. Yeah.
Perfect. And I think those are just a few examples. I know we can really get into it. So go ahead.
Yeah, and it seems to be very complicated, but we have ML.NET to help us. ML.NET is a library from Microsoft, which instead of you need to know a lot about analysis, about math, about numbers, you don't actually need to program all that analytic stuff. You just use their library, which is very simple to use. So, okay, if you want to train a model, there are 7 simple steps that I'm not going in right now, but basically it's one method calling from each one. So when you prepare a model, you build a pipeline. For building the pipeline, you just have to call a method. And then when you train a model, you call another method. So it's pretty straightforward and it's accessible for programming. So you don't have to be an expert to program that, know a lot about C Sharp, but the basics, yes. Um, the advantage is ML.NET is very quick because you build your code and then you use that code build it. It gets much more faster than other languages like Python. It has some limitations, just like Isabella told us. So we can generate incorrect answers. It's not deterministically, so you can have the same inputs and you can produce different outputs. And it requires protections and validations. But there are many ways and tools to help to improve it and try to not do that as much.
Perfect.
Just a basic context about machine learning. We have two kinds of learning. Uh, so you can have the supervised learning and the unsupervised. When you talk about supervised learning, when you train your model, you give the database that the model will be trained for, you already give the answers. So let's say that you have a historical values about alarms and process variables. Okay, the temperature is that value, the pressure is another value, and when that is the behavior, you have a failure or you have overheat. You have some problems with the bearings. You tell the AI that that's the result. So you label that data. That's what supervised learning is. And when we go to the unsupervised learning, you just input a lot of data for training the model, and the model itself can understand what's the group that that data makes part of. Um, these are depends on your process and also in the data you have available. But we'll see in the example we have to show that it makes a commentary about this.
Perfect. And yeah, so where to start? Eduardo is going to show us a little bit of an example how to get that going. Um,
Okay, so we were talking about the LLMs and how that helps us a lot. So let me share my screen here to show a easy example. Okay, share. You should be seeing ChatGPT in my screen.
yes, give it a second. There you go.
So usually the when somebody starts thinking about machine learning, the question is, how do I start that? So using the ChatGPT is a very good way to do that. Uh, sorry. So in this example, I just described what was my process. You can do the same. So I just say, I have an industrial motor. This is a centrifugal pump assembly. And I collect the following process variables that are sampled every 500 milliseconds. And then I describe, okay, I have the temperature, pressure, flow rate, and a couple more. And then I say, okay, tell me 2 practical ways to apply machine learning using these variables.
Nice.
And then the ChatGPT will tell you. Okay, so the first one is you can use predictive maintenance. And the goal is to detect degradation, bearings, cavitation, clogging, any kind of issue that you can see in a machine. And then before that happens, you can trigger an alarm so the operator knows what's happening. And how does that work? So there are 2 ways that I just make a commentary. You can have the supervised and the unsupervised. If you already have that data label, this is okay. When the process variables are in this state, you have the overheating. You would use the label the supervised. But if you don't have any of that, you can use the unsupervised. And okay, what do I use to feed the model? that's the inputs that we were just talking about. So you can use vibration, motor current, thermal behavior, and your output expected is a health score. So from 0 to 100, meaning that 100 can be closer to it found an anomaly, and the 0 can be, okay, it's fine with the machine. You can have, oh, the top contributors is very cool, because if you have like 15 process variables, you can plot in a trend visualization or bar graphs which is the process variable that has more impact to
Oh,
what's
nice.
happening. Let's say that it could be overheating. In this case, probably the temperature would be the biggest bar, or maybe the speed. Okay, this is the first example they gave us. And you can also use performance monitoring and optimization. So the goal is to keep the pump efficient as much as it can. And how it works. So, okay, you build a model and then you want to know the predict flow that you have in the future. You can predict the current, the pressure. And in this way, you can optimize your model. Usually, the outputs will be, okay, you are 20% off expected pump curve behavior. In this way, you know which process variable you have to move to get it better. And you could ask anything to ChatGPT and it would help you. In fact, we were talking about all the algorithms you can use, and it also mentioned, okay, you can use anomaly detection for one example, you can use regression for the other one, and if there's anything you don't understand in this text, you can only ask ChatGPT about that, and it will talk to you, and usually has pretty good answers.
Beautiful. We recently had a webinar around machine learning, and I'll talk a little bit about it in a sec. But one of the things we said there is that when you are starting, there's no need to kind of try to solve everything at once. Our recommendation is really to start small with one issue, one answer you want. And Eduardo's suggestion here is great, because then you can just throw in the data, see what it suggests for you, and kind of figure out where you want to start, like one data point, one answer to really get the most out of it. So yeah, and that was all on ML. I do want to talk a little bit about MCP before we close this up. So can you explain it a little bit to us?
Sure. So let's say that we have two sides. We have frameworks in one that you are collecting data from the field. In tags, you have historian values for those tags. You have alarms being generated in real time, and you will also have some custom methods that can be C# methods. And then in the other side, you have the LLMs, which is Cloud AI, ChatGPT. And let's say that you want to make a question to ChatGPT. You want to ask what's the temperature in some specific tag in your solution. So what you do is to ask ChatGPT, and it will retrieve information from your framework's application in real time. And that's possible because there's something called MCP server in between the two, and it communicates with MCP protocol, making possible to do that. We also have the webinar we did that Isabella was talking, a demonstration of how the chat with Cloud AI would work. And you can retrieve information from alarms in real time, from historian, and yeah, you can also build your own methods that you want to retrieve information to the LLM.
Perfect. I thought it was worth mentioning. Well, most of this was around machine learning, but I think MCP is also a new technology around AI that it really can get a lot of. So yeah, we have documentation around it, examples, tutorials. You can play around with it. Um, so yeah, I will recommend to anyone who watched this. Now that you've got the basics on AI, to really take a deep dive and watch our full session deploying AI on the plant floor. It goes a little bit deeper into machine learning. It has an actual solution example around ML, and also a little bit of an example around MCP. You can find all of that in our page, tedtalk.com/ML. It has the documentation I manage, the full video, and a lot of other resources, including the software you can download and start playing around with it, figure out how it works for you. So yeah, Eduardo, thank you for being here. I appreciate it. Like I said, this was a little bit of an intro into the basics of AI on this space. I think it's important to give everyone that overview. I appreciate your time. Um, if you guys have not followed our channel, please do so. Leave a like. That also helps us. If you have any suggestions for for topics and things like that, do let me know. And yeah, follow our socials to to know when the next technical Tuesdays are going to be like. Eduardo, any last thoughts?
No, that's all. Thank you.
Thank you. I appreciate it, guys, and we'll talk soon.